What is this? A toolbox for ants? Why yes, it is. This is my new mini toolbox, and in this video I'm going to be outfitting it with all of the tools that I need for my ant weight combat robots. But why go to the effort of making all of my tools fit into this tiny little toolbox? Well, I'm tired of lugging all of this junk to every single event. Let's get started. How's it going, guys? Angus here from Muse. So if you're in any sort of competitive engineering style sport like first robotics or combat robotics, then you'll know how important it is to have the right tools on hand for those desperate repairs between rounds. And even after being involved in combat robotics for most of my adult life, I still genuinely just grab the tools I think I'll need, chuck them in the car, and half the time I end up not having all the tools I actually need, or I'll forget that I've put those tools into the robot bag and I won't be able to find them for months after the event finishes. So I think we can do better. I was recently browsing Super Cheap Auto, which is an automotive store here in Australia, when I came across this little toolbox. It is absolutely adorable. Now, I have seen these miniature toolboxes before. I'm sure you come across them in your own tool stores, but often they're really not usable because they have metal on metal slides and they're built like crap, so they can't actually function in any way. They just look kind of cute. But these ones are different. They have proper bearing slides on each of the drawers, and they have a really good build quality. They're solid, they're heavy, and I think it'll be the absolute perfect candidate for a customized mini tool chest to make sure I always have the tools I need on hand, and I know exactly where to find them, and most importantly, where to store them away. Because that's right, we're gonna use 3D printing to organize this thing. But this toolbox really is tiny. We only have this space at the top and two very small drawers to work with. So I think before I begin, I need to figure out exactly what tools I need for robot events and how I could possibly shove them in to this tiny space. So currently for Antweight robot events, this is what I bring. These two, I think they're shoe boxes, these two plastic shoe boxes. They're definitely not the smallest, and they're not very elegant, and they're not very organized. I just chuck tools in and I hope I'll have what I need at the event. But often when I come back home from the event, I forget that I've left tools in here. So when I need them for projects around the house, I can't find them. So what I'm talking about in terms of keeping a robot running are the screwdrivers and such to remove screws and let me get into the robot to change batteries. The charging system, so that's how I charge the battery between fights. Things like the soldering iron and multimeter, that is letting me work on the electrical systems of the robot. Side cutters, pliers, tweezers, that kind of thing where I need to do repairs. Because Antweight combat robots are only 150 grams, they're really tiny little things, very finicky. But tiny tools means hopefully they'll fit into our tiny toolbox. So let's begin. Cracking open this top one here. First thing we've got is this little tiny screwdriver set. This is one of the nicest screwdriver sets that I've come across. High quality small screwdriver sets are really important for Antweight combat robots because you're often working with really tiny sized screws, like down to M2 or even smaller screws. I found this at Sydney Tools here in Australia. It wasn't too expensive, but it's actually originally a mobile phone repair kit. So the case is really nice, but do I need any of this extra stuff? These tweezers are pretty crap. And that, do I need the little suction cup? No. So what I actually need from this is the screwdriver handle. The extension is handy as well. And of course I'd like all the bits. So these are the bits. There are certainly bits that I'm never going to use, like they're specific to mobile phone repairs, like the tri-head ones. Probably never going to use those. But these little holders are really nice and compact, and they actually have little labels showing what bit should go where, which is really good for organization. So if I can fit them into place, I might just keep them with the set. And then there's a nice little nut driver set as well, which is very useful for tightening up tiny little nuts in the robots. The case is really nice, but it takes up too much space, so we're left with this. Next up is this nice little kit. So this is already a 3D printed organizer for two really useful items, the OmniFixo and the Pine-Sil soldering iron. The OmniFixo is this really nice work holding jig set for soldering that has these really nice magnetic ball joints and a steel plate. It lets you hold delicate components in place while you solder them. And it pairs really nicely with the Pine-Sil, which is a very high power USB-C or barrel jack powered soldering iron. And it is tiny. This little kit is already really nice and compact, and it's actually more than enough for most people. But I think I can actually take some cues from this design and incorporate it into the new toolbox. Because I like how it's laid out, it's very compact. and it's definitely something I want to transfer over so I can keep the Pine Cell and OmniFixo set all nice and organized for those inevitable repairs. And of course we have the important USB-C cable, and I genuinely use a mobile phone charger, which is usually in my backpack to power the soldering iron, so I don't need to worry too much about packing that into the toolbox. Then there's multimeters. This is how you check for continuity in your circuits, check battery voltage to make sure your batteries aren't sagging too much, make sure the cells are balanced. This is a nice little pocket multimeter that I've had for many years. It was really, really cheap off AliExpress. You always need a little bit of solder for your electronic repairs, but this is way more than I'm gonna need. And then the rest of the stuff in here, we've got an LTT screwdriver. This is a custom one I did at the actual LTX Expo. And it's great screwdriver, but it's quite large. A big chunky pair of slide cutters, definitely too large. We are gonna need to go with a smaller one. Let's move on to layer 2. This is where most of the tools that I use for the repairs are stored. So we've got some other screwdrivers here. Now, for the robot switch, I generally use these tiny little hex drivers. So I will need one of these at least, but will I need these other ones when I've got that multi-set screwdriver set? Probably not. Do I really need a battery-powered screwdriver? It's nice, but it's pretty chunky, so probably not. I really like these Knipex side cutters, and actually they sent me these and a few other tools ages ago, and I found them to be really useful for robot events because they're nice and small, they're very precise, so big thanks to them for sending them. They sent me duplicates, so I used some of them as prizes for one of the previous Antweight robot events. So a massive thanks to them. There's some information on Knipex in the description below. Needle nose pliers are also really handy for repairs. This is just a cheap pair and definitely one I want to keep on hand. And then he's got these bad boys. So these remove stubborn screws. And if you have a damaged screw, like in a fight, a screw head might get damaged, you can't remove it normally, these can get them out. So even though these are quite large, I've had them for so many years and they're indispensable for robot events. I use them for my combat robots, big and small, so I definitely need to have these on hand. Capped on tape stops things from shorting out, so for our electronics set, definitely need that. Nice little pair of flathead tweezers. I find these are much more useful than the sharp tweezers for grabbing delicate wires and doing delicate electronic work. I've got this baby vice grip. It's one of the most adorable vice grips I've ever seen, but these are also really handy for grabbing components when they are damaged and removing them. And also they make a great impromptu weapon lock for the smaller weight classes if you forget to bring one, which I often do. And I also want to have a knife on hand for trimming away bits of TPU frame and modifying robots in a sort of desperate fashion between rounds. And this folding knife has proven to be fairly useless, and also it's pretty blunt now. But I actually found a 2 set of these in Bunnings. This is a tiny extendable knife that uses razor blades, which are really, really sharp, and it's really well made. It's metal, it's solid, and they were really cheap. For a pack of 2, they're Ryobi branded. So they're nice and small, and this will definitely fit into our little kit. Finally, I need to keep the batteries charged between rounds, so I picked up this Vifly tooth store. I don't know what the name's all about, but this is a charger that can do 4 2-cell batteries at once. Now the batteries you use in Antweights are tiny. They're like 200 milliamp hour packs, 2-cell packs. So this is more than enough, and this can run off USB-C as well, which is really handy because it's the same as soldering iron, so I can just run these all off a powerful phone charger and not worry about having to bring all these adapters or other electronics to the event. So here's all the stuff I think is absolutely critical for a Antweight combat robot event, and it's all gonna go in here. But there's no point in having an organized toolbox if you don't have a robot to compete with. And these are just some of the machines I've built over the past few years, thanks to this video's sponsor, PCBWay. PCBWay is like having a PCB fab and machine shop right in your pocket. Anyone can use their services to turn their digital designs into high quality parts, like these little combat robot discs I designed to mount onto low-cost brushless motors. Let me show you how it works. You design your part using CAD software and upload the design to PCBWay.com. This could be either a step file for CNC or 3D printing, or Gerber files for PCB fabrication. Then from there you can choose what material you want your part to be made from. I want these little discs to take a beating, so I chose 4140 steel. Submit your design and then a real engineer will look over your design and let you know if it's suitable for the process or if any changes need to be made. Once they've given it the green light, you'll get an adjusted quote to pay, and then in next to no time, your parts will arrive at your door. You can use my coupon code PCBWay-MakersMuse10 for $10 off any order of $30 or more, so why not give PCBWay a go for your next project? You can find out more information in the video description below, and a big thanks to PCBWay for sponsoring this video. So when it comes to designing well thought out 3D printed organizers, whether it's for tools or anything else, There are 4 ways you can go about it. You can trace the parts by hand onto a piece of paper and scan the outlines into the computer to use as references. You can take a photo of the parts and then use AI services to trace the outlines for you. You can get down and dirty with a pair of calipers and some patience. Or finally, you can borrow the excellent work already done by others in their 3D designs and incorporate that geometry into your own. I'm going to go through each method individually, and there is timestamps to each, but of course you can use them interchangeably to best suit your design requirements. One of my favorite old school methods of converting weird organic shaped objects into lines that I can use as references in my CAD is to literally just trace them with a marker onto a piece of paper. So you get the tool, put it down, trace around it with a marker, and then what you want to do is get a metal ruler and put it on the piece of paper and scan it. So when you scan it, you'll get an image, and you can then bring this image into your CAD software as a reference, and then you can adjust it using that ruler to make sure it's the perfect right size. Now, I know you can do this with DPI, sometimes with scanners, but trust me, using a ruler is a really great way to error check to make sure everything is at the correct size. From here, you can manually just trace over those drawn lines with splines, or if you really want to, you can use software like Inkscape, which lets you convert an image like a PNG into vectors, which is an SVG. And once you clean up this SVG file, you can then bring that into your CAD software like into Fusion, and then use that SVG as a sketch to then create your extrudes and cuts and then create a detail that way. I find this method best for weirdly shaped objects, but not great if you can just grab dimensions directly from them, because it's hard to get things lining up precisely in the CAD software. Yes, you can just nest them manually onto the piece of paper and trace around them, but they're not going to be perfectly lined up, which might be an issue. The next option is to use a service like Tooltrace. Now, I first came across this program through a CNC kitchen video, which is linked here, but this is an AI service that lets you trace the outline of any parts that you place down onto a piece of paper. So what you do is you get your objects, your tools, your parts, put them on a piece of paper, then take a photo, and then the service will correct any lens distortions or parallax from that image, and then figure out through object recognition the outline of those parts to create the inserts that you can then 3D print or export to other software, or you can even create a gridfinity bin directly in the program that you could 3D print and use in that system. The next method of creating custom inserts is to measure the parts precisely with a pair of calipers, for example, and incorporate those measurements into a fully defined and dimensioned sketch. And that's what I did for the screwdriver and its bits and the battery charger components of my insert. This is obviously only possible with simple objects that you can grab precise dimensions off, but it lets you be really precise and nest things in really tightly into that insert. You can line things up perfectly with each other and pack as much as possible into that part. I'm particularly happy with how the screwdriver insert works. It's created using a sketched cross-section of the screwdriver handle, which was then done as a rotate cut out of the model. Then I did an additional extrude cut, which removed the top half of the material so I could sit the screwdriver handle snugly into place. As with all the other methods, don't forget your finger holes, because a tool insert is useless if you can't get the tool out when you need it. So I made sure to incorporate a nice chunky one, which let me use just one finger to scoop the driver out when needed. Things don't have to be too precise here, so be sure to add some generous clearances as well, because you don't want to have to be jamming things in place perfectly for everything to nest together. So depending on where it is in the part, I gave myself 0.5 to 1 millimeter clearances between walls to make sure the parts fit just fine without having to fiddle with them too much. But what if you come across an already excellent design online, but you need to modify it for your own use? Well, that's where the last method comes into play, borrowing existing geometry from other designs to use in your own. This is how I created these cutouts for the Pine Sill soldering iron and the OmniFixo kit. First, you need to find a design online that you like and suits your needs. I mentioned before that this combo of the Pine Sill and OmniFixo is already a remix of an excellent design by user Burger Beagle on Printables, great name. And because it's been uploaded as a step file, it's incredibly easy to import into your CAD program of choice to modify, or in my case, copy the insert geometry I needed for my version. To do that, you'll want to first open up the step file, and our goal here is to turn all of those voids into a solid body. which will allow you to move that geometry into place in your own design and effectively punch out the details that you want exactly where you want them. What you want to do is create a sketch on the top surface of the part and then extrude a nice chunky block all the way through so it encompasses all those voids but doesn't extend past the base. I use the extent type toObject, which is an easy way to get this precise. Make sure this block is a new body so it doesn't join to the existing geometry, and then we can use a Boolean difference to cut this new block away with the existing part, leaving all of these voids as solid geometry. This is done in Fusion using the combine command, selecting the target body as the extruded block, and then the tool as the original part. What you'll be left with are all of these solid bodies, which you can now use as physical stamps to create new geometry where and when you want it. I simply trimmed away all the geometry I didn't want, then I created a new component for my toolbox insert, and I simply moved the bodies I wanted into position, and then I did another Boolean difference or combine cut to recreate that excellent geometry that was already perfected by Burger Beagle and Lotex. So don't reinvent the wheel if you don't have to, because there are a ton of excellent insert designs out there that you can just reuse in your own designs. Just be sure to credit the original designer and make sure you honor the licenses. So as such, my insert is now available on printables, and it's technically a remix, so I've linked back to the original designs. And there you have it. This was the 3D printed result on the Snapmaker U1. Got it right first time. Yeah, ignore that. Okay, no, but seriously, it did take 3 goes to get all the clearances right because it is an incredibly detailed part. There is no space wasted in this little tool holder design. And I actually ran out of the yellow PLA right at the end. I actually had to switch to a gray PLA, and it actually looks pretty good. So the moment of truth, does it fit? Well, it's tight, but she fits. So let's fit it out. First things first, start with the easiest, the charger. That actually just sits in where the cutout is, like that. So there's nothing apart from the edges of the toolbox and the edges of the cutout holding it, just like that. Next we have our OmniFixo parts, so they go in just like this. And this is all directly copied with the method I showed you off that amazing OmniFixo kit that I was using previously. A little soldering iron stand and the sponge for cleaning the soldering iron tip. I have a tiny bit of solder here, which just sits in there. You could have more, you could use it for other things. And little magnets that we have that hold the ball joints. It's different to the other design. I actually ended up making a hole here that actually magnetizes them to the bottom of the tool case because it is magnetic and locks it down there and actually helps to hold the whole thing in place as well. Now we have the little extension for the screwdriver that actually sits underneath where the soldering iron goes, the pine sill. Pine sill sits in just like, oh, it's tight. Come on, like that. It's filling up. And then we have our screwdriver that sits in just like that. Very nice. And then all the bits. Now again, like I said, we don't have to use all the bits, but I do like the little holder they have with the little icons. I couldn't 3D print anything this fine, so I decided to just go for it. And they don't take up much space as is anyway. There's enough room for all 3 plus the nut drivers, just like that. Nut drivers sit in behind. And there's even room for a few additional little things because I figured with this on the table during events, you're gonna be using tools like, say, using a screwdriver, using it for various robot repairs, and then you need to put it down. Just put it in one of these, or put it in these little holes I added in. Or if I have the driver they use to turn the robots on and off, I can just put it there as well. And it's really handy if I'm taking tools out of the other toolboxes to put them in so they're ready to go. Because the thing about these robot events is they're hectic. You only have a few short minutes to do your repairs, so everything needs to be within grasp. What do you think about the little toolbox, Prince? You like it? Pretty good. You're blocking the camera. Get your butt off. But you may be wondering, well, where does a little OmniFixo base plate go? This little thing, where do I put it? Well, you see, because of these little magnets, you don't actually need it. You see, if I close that lid, they stick right there to the toolbox. So I can actually have these stuck anywhere I want, like that. I can have it open, and I can do my soldering and repairs right here on the toolbox. It's sheet steel, it's really solid, but there's a few things I still want to change. Starting with the fact that this lid doesn't open all the way, because I want to take advantage of this steel surface as a battery charging surface, so in case anything happens, it's not going to burn the place down. Unfortunately, the design has these little tabs that lock the lid at a 90-degree angle, so they'll have to go. Initially, I thought I could just pry them out of the way with a screwdriver, which was a terrible idea. So when my sensors returned, I realized that the entire hinge pin could be simply pushed out, separating the two parts. From here, it was just a simple case of pulling the tabs off one by flexing them back and forth using pliers. This process introduces metal fatigue, which makes the metal get more and more brittle until it just snaps, and it's a little bit like bending a paperclip too many times. This worked really well, admittedly a little bit too well, because now the lid hangs too low. But it just so happens I also have this chunky magnet for keeping screws organized, and it perfectly sits and attaches to the rear of the toolbox, and it locks the lid at a near perfect 180 degrees. And it actually holds there pretty securely, even if you add a little bit of weight to it. Also, just a side note, I store my tiny ant weight sized lipos in this adorable mini shipping container, and I just 3D printed this TPU insert to hold them securely in place. You can find these on AliExpress really cheap, and they've got all the different brands. I don't know how legal that is, but they're adorable. And I think it should do good just to keep any lipo mishaps from spreading, because again, it's metal. Though I also do carry this tin in a larger lipo bag when traveling to events, just to be safe. I figured that there was even more room I could utilize above the soldering iron section, so I designed this tiny little tray that could be useful for keeping screws and parts organized during events, but it also should help keep everything from shifting if the toolbox gets jostled during transport. Unfortunately, I couldn't find a good spot inside the toolbox to store the crucial USB-C cable for the charger and soldering iron, so I had to get a little bit creative. The toolbox has these funny indents on the side to mirror its full-size counterpart. They don't really serve a purpose other than acting like a kind of crappy handle. To take advantage of this little bit of extra space, I designed up these little boxes with magnets fitted to the underside, and these 6mm diameter neodymium magnets are very strong. They securely snap the boxes into place thanks to the steel body, and they're not going anywhere. On one of the sides, I modeled in this little detail that lets me insert the coiled USB cable, and it does a pretty good job of locking it into place. And on the other side, well, that's for emergency use only. That's the stuff. But as it is now, this thing is really hard to carry, so I definitely need a handle of some kind. So I started to design my own, printed from PBT plastic and a chunky M4 bolt to support a custom band. These were to be secured on the side of the toolbox with another long M4 bolt that goes through the outer and inner steel walls, so it's plenty strong. But after putting all of that effort into a custom part, I found this in my stash. It's a little bit of techwear from Machine 56, I think, and I've just had it lying around the house forever looking for a use. And hey, well, you look at that, it fits perfectly. And this little toolbox is almost there. It just needs something. Yes, it's just a tiny toolbox, but I love this little thing. And this little thing as well. I'm actually so excited to be organized for once for one of these robot combat events, because since I got involved in the sport back in high school, I've just been chucking random tools into random boxes and hoping for the best. And yes, granted, this little tiny toolbox is only really useful for servicing tiny robots, but now I can just grab it, bring it to the event, and when I'm done, just put it back on the workbench to use until the next event. Plus, it just looks so professional. I love how the lavender and yellow and gray color scheme worked out, even though the yellow was largely by accident. Now I just need a real ant-weight robot to work on, and not this completely fake one that I 3D printed in multicolor on the U1. You thought it was real, didn't you? But what about gridfinity, and why didn't I use it? Well, I did test it out with this excellent plugin for Fusion, Gridfinity Generator by Lev Mission, but unfortunately I didn't find it overly useful for the kind of components I need at these events. Custom Gridfinity bins look pretty and organized, but they take up a ton of space, and I don't really need a design where I take the bin out and put it back in. I just need something to hold the tools that I take out and put back in. But I haven't discounted it completely quite yet, because it just so happens that Supercheap Auto released this. That's right, this is a mini cabinet tool chest, and of course, they stack. And for this cabinet, which won't go with me to events, I've already started to investigate if Gridfinity is suitable for storing various parts that I need for these robots, and I'll report back. And I finally want to address this bottom drawer. Sometimes the best 3D printed insert is none at all. There is no 3D printed organizer that would make this drawer more efficient. It would just take up space and get in the way. In the thick of it, tools get used and put back rapidly. If they can't just go in that moment, you can bet that they'll end up on the table instead, and that's something I really want to avoid at these events. If you'd like to create your own mini custom toolbox, you can find my insert over on Printables. It's there to maintain the lineage of remixes, and remember that you can use code PCBWay-MakersMuse10 to get $10 off any order of $30 or more on your next batch of custom bits from PCBWay, who sponsored this video. Thanks for watching, guys. Bye.